All right, today we're looking at lesson 6.5. This is Algebra 1, graphing linear inequalities in two variables. First goal we have is to graph a linear equality in two variables and then use those types of things to model real-life situations, beginning on page 360 in the textbook. Got a few definitions to start. A linear inequality is an inequality in x and y that can be written as follows. A times x plus by is less than c. Ax plus by is less than or equal to c, or ax plus by is greater than or equal to c. So it's just like an equation, except it has, instead of an equal sign, it has an inequality sign, be it less than, greater than, or any combination of either one of those with or equal to. A solution of a linear inequality is an ordered pair that makes it a true statement. So when you graph this, and we'll be doing this shortly, when you graph an inequality that looks like this and we have it shaded on this side, a solution would be an ordered pair that falls on this half plane. We'll talk about what a half plane is in just a minute. So if there's a point, let's say this point right here is 7, -3. This point right here, 7, -3. That falls in the half plane. It makes it a solution. If we use the point 0, 6, this one here, that point, it's not in the shaded area. That would not be a solution, the second one. A graph of a linear inequality is the picture that you graph, the actual picture of the inequality itself. The only way to actually solve inequalities is to show the graph. When we had single variable inequalities like x is greater than 2, and we graphed it on a number line like this to where 2 was here, we had an open point and we shed everything that was larger than it. The graph is what's underneath it. This is what we said was solved when we were talking about the inequality. But when you're doing it in two variables, it has to be a picture to represent it. Like y is greater than 3x plus 1. We have to know that that begins at 1 and it goes up 1, 2, 3 and over 1 for our second point. And then again, it's going to be a dashed line or a broken line, and it'll be everything that's greater than it. Greater than is not quite as easy for most people to understand, but 0 is greater than 1. That's not true. It would be everything to this side. We'll talk about how to do that in just a few minutes. And then a half plane in a coordinate plane, it's the entire region on one side of the boundary line. When you make a coordinate plane like this, you create 4 regions. You create quadrant 1, 2, 3, and 4. We know about quadrants 1, 2, 3, and 4. We're taking it a step further. On the plane itself, when we're actually drawing an inequality and we're shading it one way, we're creating one plane that is correct and one plane that is incorrect. Everything shaded to the green area up here would be correct. Everything the other direction that's not shaded, now it's shaded red, would be wrong. So we're creating half planes. Example number 1 is checking solutions of inequalities. Almost always we're going to use 0, 0 because it's easier. But there are times when you have to use 1, 0 or 0, 1. In this case, they just have you use 1, -1. You can actually choose any point you want to choose. The only ones that you can't use is if they're on the line itself. But here all we're doing is checking algebraically to see if it gives you a true statement. Is 0, 0 a solution of 8x minus 4y is greater than or equal to 3? What we're doing is we're plugging in place of x, we're plugging in 0. In place of y, we're plugging in 0. Again, the reason we use 0, 0 is because it's the same for both of them. 0 is the easiest thing to multiply, but you don't have to remember which one is 0 and which one is another number. 8 times 0 is going to be 0. Minus 4 times 0 is going to be 0. You're going to get something that says this: 0 is greater than or equal to 3, which is that's not a true statement. 0 is clearly not, this is false. You're checking truth value with this stuff. That's not true. And since it's not a solution, you would shade everything the other way. We'll get to that in just a minute. But for this, though, this next one, Check and see if 1, -1 is a solution. In place of x, we're plugging in 1. So now in place of x, we're going to plug in 1. And in place of y, we're going to plug in -1. Again, notice there's a different numbers. One's 1 and one's -1. That's why, again, we use 0, 0, where you don't have to remember which one is which. 8 times 1 is 8. Minus 4 times 1 minus a negative, this gives you a positive. So 8 plus 4, that's why it comes out to be the number 12. Is greater than or equal to 3. That is a true statement. Therefore, you would shade towards that direction. Let's look at some more like that. Check whether this ordered pair is a solution to 4x plus 5y is less than or equal to 12. Take about 20 seconds on that. Okay, again, remember which one's which. This is x, the other one's y. 4 times x is 4 times -3 plus 5 times this one's y, 5, is less than or equal to 12. Do it like this. -12, 5 times 5 is plus 25, is less than or equal to 12. -12 plus 25, you got to subtract them. You're going to get something that says 13 is less than or equal to 12. Remember, the big mouth eats the big number. This is a false statement right here. That's false. Plugging in those numbers. Again, that's -3 and 5. Almost always with this stuff, you're going to be using 1 and 0. Do this one real quick. Take about 20 seconds. Okay, again, 0 and 2, real easy. This one's x, the other one's y. 4 times 0, remember, anything times 0 cancels it out. Plus 5 times this one's y. 2 is less than or equal to 12. We're just going back to that original inequality. That part canceled out. 5 times 2, we know is 10 is less than or equal to 12. The big mouth eats the big number. This one is true. And then do the last one. 6 and -8. Take about 30 seconds on this one. All right, again, for this one's x, 4 times 6, plus 5 times this one's y, -8, less than or equal to 12. 4 times 6 is 24. 5 times -8 is going to be -40, is less than or equal to 12. You might not be able to do 24 minus 40 very easily, but you know that when you put these two together, you're going to get some kind of a negative number. So just in terms of checking the truth value, something negative is less than or equal to 12. You might not know that it's -16, but you know it's negative. It's going to be true because it's a negative number. And again, all of these steps were not necessary to write out. If you could just do 4 times 6, you could just write 24, -8 times 4, times 5, -40. You can do those together without having to write everything. Going back to the front of the page, these are the steps for graphing a linear inequality. Notice, graph the corresponding equation. Use a dashed line if it is greater than or if it's less than, not or equal to. Okay. Use a solid line if it has the or equal to part, greater than or equal to or less than or equal to. Another word you'll hear instead of dashed line is broken. So if you see that word broken or you hear that word broken, it means the same thing. It's just like saying color the bubble in or darken it in or blacken it, just different words. Broken versus dashed. Step number 2 is the line drawn in step 1 separates the coordinate plane into two half planes. You're creating a boundary. One side's going to be right, the other side's going to be wrong. Then you test this a point, you test the solution. You shade it if it's true, you shade towards that way, you shade the other way if it's incorrect. You don't have to find a point that's true. You just have to see if one of the points is true or false. Shade the way it is if it's true, the other way if it's not. Is example 2. Sketching a linear inequality. When you're sketching graphs in two variables that only have one variable, I know that sounds funny to say that, but when you're sketching it in two dimensions, when it only has one variable, it's either going to be a vertical or a horizontal line. In this case, we're sketching x is greater than 3. Graph the corresponding equation. X is greater than 3. Remember, when you're looking at your plane, this one's your x. So at 3, you're always going to have, it's always going to be 3. Like if this was an equation, it would just be like this, and you'd be done at the number 3. We're making a vertical line. It's a dashed line. That's the first difference because it doesn't say or equal to. So I know this is hard to see, but this is actually dashes, not a solid line. That's step number 1. Then test a point. Always use this point right here unless the line goes through that. That's the only time you don't want to. That's the easiest point to plug in the number 0, 0. You get something when you plug it in for x. 0 is greater than 3. We know that's not true. That is false, which means everything over here, that half plane, is wrong, which means everything on the other side has to be correct. So then shade to the right. Don't shade the way I just did to show you what was wrong. I can hit a back button up here to make it disappear. When you do that, you make a mess. All you have to do to shade is just like I just showed you, like put like 3 lines going to that side. This gets extremely messy. So the neater you can keep it, the better off you'll be. Sketch this graph. We'll go real quick and then we'll be running out of time. X is greater than or equal to 1. Take about 15 seconds. You have to know that this is your x-axis. Where x's value is 1, it's going to cross through the whole time. So we're creating a vertical line just like the other one. This one, unlike the example we had, this one says or equal to, not just greater than. So we're going to make a solid line, not a dashed line. Now we know that our positive values are this way. So we could shade everything this way since it says greater. Or we cannot trust that and say, okay, well maybe I got to plug in 0, 0 to make sure. 0 is greater than or equal to 1. That is not true. And that's the reason we shade everything this way. Remember, you shade opposite the way if it's false. And then we'll go over the rest of this tomorrow.